This video will demonstrate some analog experiments, some analog concepts which can be made using 20sim software and downloaded on ARM9 board. This video demonstrates the complete flow, that how various kind of signal generations can be made using 20sim software and how you can make use of an ARM9 board and execution of those experiments in them. Let's start with a simple experiment where we take a couple of sine waves and multiply them to see the results. So I go to the sources folder and look for a sine wave. Yes, there I have. And I take a single monitor. So thereby I see that this is a simple sine wave. Yeah, okay. I can modify its angular velocity. Instead of angular velocity, I use the revolutions per second. So let's say the value is maybe 3 Hertz. Okay. So you can see the change in the frequency. Yeah, this is working good. Now I just duplicate the sine wave. I just copy and paste. And I join this to its own signal. I see it's multiply, so this is the option I would like to have. So now I'm multiplying two sine waves. So the result would be seen something like this, as they have the same frequency. Okay. So I'm changed the second sine wave frequency to be as something 200 revolutions per second. That's 200 Hertz, and that is what is expected. This is what you can see. Maybe I little bit reduce it to, first I try something like 100. Okay. Something like an amplitude modulation signal you would should be able to observe. The only thing is that I see an output waveform ranging from -1 to +1, whereas my DC support from 0 to 5 volts. So I would like to have a change of offset for the signal, so which I can do by adding in mathematics to it. So I'll look for a block diagram, and that is a gain block. Or yeah, maybe it's just a constant will do. That's so I take a constant signal and I join with the line. It's a plus minus. I say plus. So the default value of constant is 1. So he should be adding a 1 to it. And let me observe the output waveform. Yeah. So now you can see the signal ranges from 0 to 2 volt. So this should be able to work on my DAC very well. Now to download this experiment in the hardware, the 4C toolchain can download any one of the submodel block. So I have to make the entire schematic into one block. So I select all the components which I wish to download, right click and say import. So it will make a submodel for which I can change the name. So I just name it sine multiple. Yeah. So this works as good as the previous one. I change the integration method to Runge-Gupta 4 with the sampling step size of 1 kHz. So there is hardly any effect in the simulation result. Now I wish to download this experiment in the ARM board. So I go to Tools, Real-Time Toolbox, C code generation. Select the 20sim 4C toolchain, which will not only convert the code into C code but also will help you to interface with the ARM board. So I select the submodel sine multiple and OK. So a couple of pop-up messages and thereby. So I select the target board as 7300. The further experiment recording I do on the camera. Hi again. This is Vinay here, and in this video I will demonstrate another experiment that we talked about. That is, we have added multiple sine waves together and we are generating an output and try to see its output in the real world hardware. So that is what is expected output, and the hardware I have is a TS7300 board along with an analog to digital converter add-on module. So it has 16 analog input channels and 4 analog output channels. The output DAC are resolved at around 12-bit and the input channel resolution is 16-bit. I have a CRO here and a functionality which I might use later. So let's download this code and see how does it work in the real world. So I just go to real-time toolbox, C code generation. The 20sim has capability to convert any model into a C code. So I select 4C toolchain and the sum model. I select my board setup, that is TS7300 from the list of menus. So 20sim 4C toolchain support variety of other hardware boards. So you can see that it shows that I have discovered one target board. And now I go to the connect block. So as my block has only one output, so I will connect to TS-ADC16 DAC and the first channel, that is DAC A. I say OK, say apply and compile. So that's what 20sim 4C do for you. So it can not only take the C code generated by 20sim, it can configure it for the specific board, it can make connection IOs, it can compile it for you and even upload the code and execute for you. I extend the finish time to 30 seconds and now I just play the code. I upload the model and run it. So thereby you can see some sine waves signals coming out on the CRO. Yeah. So I just, yeah. So that is what you have seen in the simulation and the same what you're observing in here. It's a kind of amplitude modulation signals because I've just multiplied in low frequency and high frequency sine waves. So in a similar manner you can perform various kind of analog experiments like amplitude modulation, frequency modulation, or variety of signals you can modify. So you can see the signal has stopped. That's because it has stopped running of the code. Maybe you can just see another aspect of it. Now this time what I do is I just copy the omega of one sine wave and paste it to on top of another one. So I just pasted the value and say apply. Now both the sine wave have the same amplitude. So I just say apply, same amplitude and same omega. So I should see a double output of sine wave. So I just say run the code. So thereby you can see a sine wave generated the output. Okay. Maybe we can play a little bit more. I just stop the code and I select the omega as 60. Say apply, or maybe 100. That's better. Also the second sine wave also, the omega I make it to 100 and run the code. So thereby you can see a higher frequency sine wave at the output. Thereby. Yeah, there. You can see the resolution of the DAC. You can see some ladders coming out. Maybe I can just stop running the CRO so you can see some ladders coming over here. There you go. So similar way you can perform lots of experiments with the board. Thank you very much.